and today we're going to investigate the conservation of momentum. I've got a degree in physics and applied mathematics, and I did my doctorate in space physics. Currently I'm the geomagnetic researcher at SANSA Space Science, and my lovely assistant here will introduce herself to you.
Good day, my name is Matshidiso Nchabeleng. I am a Science Advancement Intern. I have a degree in Media Studies and also a postgraduate certificate in education. So what we basically do here is that we do outreach programs where we teach learners how to build and program robots. We offer tutorials that are science related, and yes, nice to meet you.
Okay, so welcome. Let's get started. So, in this experiment we're going to learn about the conservation of momentum, and the aim is to investigate the changes in momentum when two bodies are separated by an explosive force. For this experiment we will need two trolleys, weights, a stopwatch, a calculator, a scale, and a table, which I will explain a little bit later. And then also a meter stick and two barriers. Learners at home, you will record the results from this experiment in a table using the following headings for each trolley. Total mass in kilograms, distance travelled in meters, and momentum in kilogram meters per second. Now, ready? We have clamped barriers onto a flat surface. Let's find the mass of each trolley and add these masses to the first two columns of the table. So for trolley 1, the mass is 0.6 kilograms. And for trolley 2, the mass is also 0.6 kilograms. Now, let's place the two trolleys between the barriers end to end so that the spring on the one trolley is in contact with the flat surface of the other trolley. Release the spring by hitting the release knob and observe how the trolleys push each other apart. Okay, I'm going to repeat the explosions with the trolleys at a different position until they strike the barriers simultaneously. Okay, and we have found the mark. Each trolley now has the same time of travel t. I'm going to repeat this again, but first measure distances x1 and x2, which my assistant will record in the table. So for trolley 1, we have 42 centimeters, and that is our x1. She will convert this to meters. And for trolley 2, the distance x2 is also the same, which she will convert to meters. And what is that, learners? What is 42 centimeters in meters? Okay, now I'm going to release the spring again while my assistant records the time travel t in seconds. 1, 2, 3. Okay, and
0.78.
0.78 seconds. You can record that in the table. Now this you will use to calculate the momentum of each trolley. We're going to take this direction as negative and this direction as positive. So for trolley 1, we have distance minus 0.42 meters. So she's going to divide the distance by the time, and that's going to give us the velocity. So that's minus 0.5 meters per second. Now multiplying that by the mass of the trolley will give you the momentum.
0.3.
Minus 0.3, that is the momentum which you will record in the table for trolley 1.
0.3.
Minus 0.3. Good. Kilograms, meters per second, which are the units for momentum. Let's do the same now for trolley 2. She's going to calculate the velocity for trolley 2, which in this direction was positive. So it's 0.42 meters times the time travelled. Now we're going to calculate the velocity for trolley 2, which we said was positive in this direction. So it's going to be the distance divided by the time travelled, which will give us the velocity.
0.5.
So it's 0.5 meters per second. And learners, what do we need to do to determine the momentum now? We're going to multiply it by the mass. So it's plus 0.3 kilograms meters per second. Okay. My assistant will just show you what the table looks like now. Good. Well done. Let's move on. Okay, now we will repeat the experiment for a different combination of masses and record those in the table. We're going to add the new mass to trolley 1 and note masses of trolley 1 and 2 again in the table. I'm going to add 400 grams to trolley 1. So learners, what is the total mass of trolley 1 now? Okay, so it's 0.6 kilograms. And we've added 400 grams, which is 0.4 kilograms. That gives us a total of 1 kilogram mass for trolley 1. And trolley 2 remains the same. Now, let's find the distance where they will hit the barrier simultaneously. Let's try here. 1, 2, 3. Okay, and they hit it at the same time. Now, let's measure the distance x1 and x2 and record that in the table. For trolley 1, it's 34 centimeters, which my assistant will convert to meters. 34 centimeters, which is 0.34 meters. And that is for trolley 1. Now, trolley 2, and the distance x2 is 50 centimeters, which is 0.5 meters. Now we're going to do the same thing again and calculate the momentum for each trolley. So remember, we took this direction as negative and that direction as positive. For trolley 1, we're going to calculate the velocity now. My assistant is going to take the distance, which is 0.34 meters, and divide it by the time, which was 1.13 seconds. Okay, and now she's going to multiply that by the mass, which was 1 kilogram. Okay, so the momentum in this case is minus 0.3 kilogram meters per second. Now we're going to do the same thing for trolley 2, which moved in the positive direction. So the distance was 0.5 meters, which you will divide by the time it travelled, which is 1.13 seconds. And she's going to multiply this with the mass of the trolley, which stayed the same, which is 0.6 kilograms. Okay, and to round that off, it is 0.3 kilograms meters per second. Okay, now we're going to do it one more time, but add more mass. This time I'm going to add another 400 grams to trolley 1. What is the total now, learners? Remember, the original mass was 0.6 kilograms. We already added 0.4 kilograms and now another 0.4 kilograms. So 400 grams is 0.4 kilograms. So what is the total mass now?
1.4 kilograms.
And she will record that in the table. And for trolley 2, the mass will stay the same, which is 0.6 kilograms. Okay, now let's find the position again where it will hit the barrier simultaneously. One, two, three. Okay, not quite. One, two, three. Okay, and we found the spots. Let's record the time now. Okay, are you ready? 1, 2, 3. Okay.
The time is 1.07.
1.07 seconds. Let's record that. Okay, and let's take it back and measure the new distance x1 and x2 for this explosion. For x1, the distance is minus 29 centimeters. Let's convert that to meters, learners. And x2 is 55 centimeters, and please convert that to meters. Now we're going to determine the velocity and using the mass, the momentum for each trolley. So let's calculate the velocity for trolley 1. It's minus 0.29 meters divided by the time traveled.
It's minus 0.2.
And we're going to multiply that with the mass of trolley 1 to find the momentum.
It's negative 0.3.
Negative 0.3 kilograms meters per second for trolley 1. Now for trolley 2, we're going to do the same thing. We're going to take the distance travelled, which in this case is 0.5 meters, and divide it by the time travelled t.
It's 0.4.
0.5 if we round it off, and let's multiply that with the mass of trolley 2, which is 0.6 kilograms.
It's 0.2.
Okay, and let's round that off. It's 0.3 kilograms meters per second. Now, by looking at the table, ask yourself, what is the relationship between the total momentum before each explosion and after the explosion? Remember that the total momentum of a system is calculated by the vector sum of the momenta of all the objects or particles in this system. In this case, it's both our trolleys and the weights that we added. Now, for the first encounter, let's go back to that. Before the explosion, the momentum was 0 because the velocity of both trolleys was 0. After the explosion, we're going to take the total momentum of the system. In this case, like my assistant calculated, it was negative 0.3 kilograms meters per second plus 0.3 kilograms meters per second. So learners, that is a total of 0. Okay. Okay, for the second encounter, the mass before the explosion was 0 because both velocity of trolleys was 0, and after the explosion it was minus 0.3 kilograms meters per second plus 0.3 kilograms meters per second, which is also 0. Now for the third encounter, the mass before the explosion was 0 because for the same reason the velocity of both trolleys was 0, and after the explosion it was minus 0.3 kilograms meters per second plus 0.3 kilograms meters per second, which is 0. So, just like in collisions, the two objects involved encounter the same force for the same amount of time directed in opposite directions. This results in impulses that are equal in magnitude and opposite in direction. And since an impulse causes and is equal to a change in momentum, both cards encounter momentum changes that are equal in magnitude and opposite in direction. So in each situation, the total system momentum is conserved before and after explosion, as the momentum change of one card is equal and opposite the momentum change of the other card. Thank you, learners, for joining us today for this experiment.